All right. Remember that I always post the do files, the do file.do file, like mco.do, or stands for managed care organization.do, mco.do. You should have access to that file on Blackboard, so go to Blackboard and click on the mco.do file, and that should give you the complete program for the week here. Remember, we make the programs a little longer each week as we do more detailed work throughout the semester. We could talk about sort of the weaknesses of Stata compared to like a more complicated programming language. Is it's not really good at graphing things because of the way it saves them. So there's a big chunk of the code where it's just saving them, right? So I labeled that part you could see before graph. Save the age-adjusted mortality rates, and that's like half the code is saving things from a table and getting them ready to graph it. I like to do that just because that way it's programmed, and that way if you give it different data, it'll go through and do the thing. Otherwise, you have to make a new data set and sort of type results into Stata manually. I like saving the results, grabbing them, and writing a program for Stata like I did here to what's called store the results and then put them into a new thing for the graph. So the way Stata does that is a little clunky, and it's not, right? You sort of, if I've been programming Stata for at least 16 years now, literally programming it, like saving the matrices and then storing that as a data set and doing different things. So don't worry about all the details of that, just worry about the basic age adjustment, which is the case study in the book. Age adjustment for a managed care organization. So comparing quality of care for managed care. Last week we talked about quality of care, the ultimate quality indicators are mortality, right? Whether the patient lived or not. So let's look at age adjusted, because different managed care organizations could have different mortality rates just because the patients are older, the patients are younger. So that's why we age adjust it. But you can see the first thing we do is install the age adjuster. So mine says it's already installed. The first time you do it, it'll give you like a little hyperlink within Stata to install it. But I think you should just type that ssc space install / distrate. It'll do that. So what we have here is that's just a standard population table. I had to format it to show all the numbers in the population. And this data is straight from the section of the Fleming book on, they do age and sex adjustment. I'm going to simplify it by just doing age adjustment. But then I will do it more detailed by doing confidence intervals, which is the nice part of using advanced software. In the book, I think they just like do the numbers by hand, but then you don't have a confidence interval and you can't really compare them as nicely. So install the age adjuster, right? So add-ons for Stata. That's why it's getting it from SSC. SSC is like the place, I think it's at Boston College, where they store like the Stata add-ons. So if you write add-ons and they get approved or whatever, it goes onto the Stata thing. This population table just shows how many people there are in each age group. So not for managed care, but just some data from the population. And you use that thing to standardize the data for the managed care organization. The managed care organization data in the book has for each age group separately, 1 through 44 years old and 45 plus years old. And then if you know sort of how many people are in those age groups, then you could standardize it. See, there's the population table there. Okay, there's the managed care organization. Now, BGW, this is right from the book, is Bluegrass West and Bluegrass East. Two managed care organizations. Managed care is sort of like an insurance company or works with the insurance company to manage healthcare and decide who gets what treatment. Sort of like a gatekeeper, right? Deciding how the doctors and the hospitals are paid and what types of services they're going to have and not have, and contracting with the government programs like Medicaid. But those are the different managed care organizations there. So for each age, you can see the deaths. That's how many people died, and for each age group, and then it's the population. And what the age adjustment does is the age adjustment, remember we installed the age adjuster, is that's going to combine them so we just get an overall mortality rate. The idea is you can't just compare the mortality rate for the two managed care organizations because the ages are different. So if one's older, they would have higher mortality rate just because they're older. And then if another one's younger, they're going to probably have a lower mortality rate just because they're younger. So what the age adjuster does is it removes those age differentials, and it makes this, they call a rate adjusted, right? You can see the rate adjusted is 337 0.15 for Bluegrass East MCO, and then it's 341.6, right? So it's that rate ADJ column, rate adjusted, age adjusted mortality rate. So you've got the managed care organization name, Bluegrass East or Bluegrass West, how many deaths, how many people total, what they call the crude, and then the rate adjusted. So the crude is just how many people died total, but the rate adjusted is adjusting it sort of on average for these different age categories. So this is the part where I'm programming Stata to save it and then formatting the data in a way you need to graph. That's the limitation of Stata. The advantage of Stata is that it's easy to do basic things in basic statistics. Like the graph command is just one line, and then the age adjuster is just one line. R and object-oriented program languages are better for graphing, but it's harder to do more. It's harder to do simple things. Stata is harder to do complicated things, but I'll just give you the code for the complicated things. And if you do want to work with Stata for 16 years, including experience where 90% of your job is being a Stata programmer, then I'm sure you will be able to write all of this code yourself if you're interested in that type of thing. Or maybe recommend R for graphs. I like using a combination in my own work. Maybe R for certain types of graphs and certain types of things. And then Stata for just sort of like overall and econometrics. And it's a little better at bigger data sets and a little bit better at econometrics. So what did the program do? So the program took the data for the managed care organizations and the mortality rates for different ages, adjusted it into a single mortality rate estimate for each of the managed care organizations, and then made the graph of it. So this is the graph that you'll include in your presentation, and you're just comparing it. So here you would say Bluegrass West had a higher mortality rate than Bluegrass East, but the result was not statistically significant. The red bars are the confidence intervals. So we've done hypothesis testing or with p-values, right? If the p-value is less than 0.05, we say it's statistically significant. Another way to do it is to compare the confidence intervals. So those red lines overlap, which means they're not statistically different, roughly speaking. If the red lines don't overlap, then they are different. Right, so we're saying what's the mortality rate? It's the height of the blue bar is exactly what it is, but that red line, that range, that interval, that's our estimate of it. And we don't really know where in that range it is. And you can see again, so they overlap, not statistically significant.